So simple trinomials, this should be a nice little recapper, nothing new here. Okay, so a simple trinomial, I can't do isolation. That doesn't work anymore here. Why? Because this has two variables in it. I know that you might see x squared and x and say that is the same thing, but it's not. So I want you to think about square footage and linear footage. If you are measuring stuff, can you put area and linear together? No, you can't put that together. That's why you can't isolate. Okay, so simple trinomial methods are to do two brackets. FOIL is opposite of factoring, so I'm going to think about that. So my first times my first had to have multiplied to x squared. So my first times my first. Make x squared. My last times my last has to be 15. And at the same time, the O and the I will add to the middle. So multiply to the end, add to the middle. So that should make you think of a 5 times 3. And you're trying to be negative 15. So that means 1 plus and 1 minus times. And I got to get to a plus 2. So you can always check your foiling. Yes, F. Negative 3x plus 5x, check. Minus 15, check. So I get frustrated when students factor wrong because you can so easily check your answer, just FOIL it out, right? Okay, and then now what makes me have a 0 in the bracket? If x was negative 5 plus 5, that's the 0, or 3 minus 3 is 0. Okay, one more. X times x to the x squared. What multiplies to 30? And at the same time, you got to get to a minus 11 when you add those numbers together. So I'm going to choose 5 times 6, because that's a set of 30, and I can get 11 out of that. Sign-wise, to multiply to positive, they both are the same sign. So now I'm choosing negative. So my x-intercepts are 5 and 6. Okay, I'm going to factor this one, but I don't like it. Who can guess what I hate about this question?
Negative.
I don't like that negative. So I always call that x squared my boss, and I don't like when it's negative. So to get that out of there, I could multiply by negative 1. But do you remember when you give children candy, what should you do? I'm going to multiply everything by negative 1 to keep it consistent. Okay, so that would look like positive x squared, positive 13, positive, and guess what happens to 0? Stays as 0. So if you have that problem, that's your strategy. Times all by negative 1. And then, can I let you finish it? Basically what multiplies to 22. Okay, that's way easier than trying to deal with some kind of negative in the front, okay? can I tell you a wrong way to write your answer? What is wrong with this person's answer? They actually made some kind of random coordinate somewhere, right? That's not what you want. Technically, do you understand that that's a coordinate? And that's a coordinate. Now this answer, does that make sense? Just writing it down improperly? I know that you know what you're doing, but then you've turned it into something different, okay? Okay, we're going to go through a couple of GCFs. So GCF is when you look at all the terms and you say, hey, they all have something I could divide out. So here there's two terms. So what is the most they both have in common? X. And because there's two terms, you're going to go bracket two distributions. Okay, so here's what I think about. X times what gets you x squared? X times what gets you negative 12x? Okay, and again, it's not quite a FOIL, but a distribution and foiling are the same thing, so you're just trying to undo that distribution. Okay, there are two x values here. You might have already saw that that one was a 12, a positive 12. Do we know what we want to make x here? What would make sense for x to be? If x was 0, that multiplier would be 0. Okay, this one has 3 terms. What's the takeout? Everything has in common. All 3 terms have a x. Okay, now because we had 3 terms, that means there's going to be 3 distributions. Okay, so here I go. X times what makes x cubed? X squared. X times what makes the middle? X times what makes the third? Okay, now you have to see something. Anybody notice something? Yeah, I heard it. Somebody said, hey, wait a minute, what's going on right there? That's a simple trinomial. Can you break a simple trinomial down yet? So you're going to factor twice. So we did that GCF, and now this trinomial could break down xx multiplies to 18, adds to 3. So 6 times 3 adds to 3. And this student right now is forgetting something big. What's wrong with what I've done? I forgot about this guy in the front. You have to keep that there. It's still part of it, right? It can't just disappear. Okay, so you actually get 3 answers out of this. 0, -6, and +3. There's 3 answers, okay? In grade 12 pre-calc, you're going to learn how to graph this function. So what we just did was called squareds, quadratics, but this is a cubic function. And when you graph it, it's going to actually have, that's it. That's the graph of it. It has 3 x-intercepts. That's what's going on. So you don't need to know that for graphing, but you will do that in grade 12. but that's just why it has 3. Okay, and this last one, okay, FYI, you could totally solve this with isolation because I only see one variable. So that would have been doable, but I told you to factor it with GCF. So let's try that. So there's 2 items here. There's 2 terms. What do they both have in common with each other that I could divide out? 8 bracket 2 terms. 8 bracket 2 terms. Okay, so here I go. 8 times what makes the first term? 8 times what makes that term? And what maybe pops out at your eyes when you've done that? AK in this zone, what is going on there? Which kind of factoring is that? It's one of them you've learned. Difference of squares. So how do you factor difference of squares? FOIL, x times x gets you to x squared. What times what multiplies to -4 and technically adds to 0, because there's nothing in the middle of this at all. So what multiplies to that and adds to 0? There's nothing in the middle. So x equals -2 or +2. So FYI, if we had isolated this, do you see why the plus minus situation works as well? Okay, and then this is just another example of a difference of squares. So difference of squares, you set up your 2 brackets. What times what makes an a to a 4th? A squared and a squared. What times what multiplies to 256? And then I need to actually make a 0 again in the middle. Is it 16? 16 times 16? Okay, now here's what I would notice. This is something I recognize. Do you see something out of that? That is actually a difference of squares again, so I can break that down more. This I don't recognize as one of my styles. I couldn't GCF something out of that. It's not a trinomial. It's not a difference of squares. Okay, why is it not a difference of squares? Because that would have to have a difference, a subtraction. So this is actually something that we would say is not factorable. Why is it not factorable? What would a squared have to be in order to create 0? What plus 16 is 0? -16 plus 16. Is this possible? Is there something that squares to be negative? No. So that's why it's called not factorable. So I'm going to leave it alone. I can't do anything with it. And then what can I do with this? We can go down, bracket, bracket. What gets me to the a squared? What gets me to 16? Okay, so I'm going to tell you that's on the test, so you need to understand that this little section here is not factorable. But then you can keep going on that other one.
Don't you isolate that data?
Which one?
This question. If you just add
Yes. Yep. But if I have as the directions you must solve by factoring, then you would have had to do this. But yes, you can do it in isolation as well. Okay, I'm going to get you into your workbooks here. So page 1 and 2. Page 1 and 2. Okay, I just want to show you on the bottom of page 2 here, though. On the bottom of page 2, I've done some factoring for you, and you're just going to give me the answers. Okay, can I just show you a super simple example like this? If this was my factor, what would be my answer? Okay, all you're doing is you're trying to make this equal 0. So what do you have to do? What kind of algebra moves do you have to do to isolate that x? Add 7 and divide by 4. Okay, can I tell you this? This is how you do it. You always do opposite divide. That's all you do, opposite divide. Okay? So when you look at question 4, we'll do it together. Okay, what's the answer for that bracket? You want x to be what in that bracket? 0? What do you want x to be for that bracket? Opposite divide. Would make 2/5. What value in this bracket? Opposite divide. -8/3. Okay? We haven't done that because over here, with the things that we've been doing, like simple, when you do opposite, it's 3, but then divide by 1. That's why we just haven't been doing that, right? Because we've just had 1x. Okay, and then I'm going to get you to do one line on question, on page 4. You're just going to do one line on this page. Can I tell you on question 1, who knows why I can't factor this right now? What's wrong with the question of why I can't start to factor? Why does this look different than every other thing we've been doing factoring? Because it doesn't equal 0. Can you change that somehow? What could you do to make it equal 0? -24. So how would it look? M squared subtract 10m minus 24 equals 0. Can you tackle that? Yes. Okay? So I can see a couple of them. So that has to be a 0 before you even start the process of trying to factor something, okay? So page 1, page 2, 1 row of page 4. It'd be a good